Good morning, everyone. So our class is now being recorded, and welcome to class number 15 of our course on Network Fundamentals for Cloud. I'm just about to start sharing my screen. Okay, I think my screen should be visible now. So we should be all set to start. Okay, so today we'll touch upon the topic of cloud network security. We've covered most of our topics in the as part of network fundamentals for cloud. Uh, we'll talk about network security today, and the final topic after this is the network observability topic. So these are the two things that we intend to cover. Uh, we'll start by taking a general overview of what do we mean by network security. Okay. So essentially, network security is all about securing not just the network itself, the network perimeter, the internal network segment, but also securing the network services. Okay? So that's what we generally cover under network security. So once we get a quick overview of what is network security, we will be able to look at how does cloud network security get implemented. Okay. And after we've gone through this theoretical understanding of network security techniques, we will actually take the case study of Microsoft Azure cloud platform. And we will see how Microsoft Azure enables network security. Okay. So, so from network security and in general, from a cybersecurity standpoint, one of the key strategies that is followed is to use the principle of defense in depth. So defense in depth is actually a military strategy, which has been which got later used into enterprise security, where network security was one of the key topics in enterprise security. How do you secure the enterprise network? And from there on, the same approach, the principle of defense on in depth has been applied in various areas of cybersecurity, including cloud network security. Okay, so the idea with defense in depth, as the name suggests, is to create layers of defense um, rather than one strong defensive line. Okay? The benefit of creating these layers of defense is that once an attacker starts to advance, they face a lot of resistance with multiple layers of these defense. Not only does it cause the attacker to lose momentum, but in the whole process of advancing through these lines of defense, the attacker also um, actually faces a lot of casualties. And from the defense side, this gives them the time to identify the attack and take some corrective measures or some corrective measures in order to handle that attack before it spreads to a larger area. So that's the defense in depth strategy. And as you can see, I mean, this is something that is followed in military. I mean, you have multi-line defense in any um country. If you look at it, there's a multiple lines of defense. The perimeter is secured by the border security force. Uh, you have additional police force inside to protect cities. Then you have special purpose guards as in CISF for industrial security. So you have multi-line defense. Right? So that's the idea of having a defense in depth approach. So historically, um, even before cloud networks became um commonplace, the idea of network security was largely applied to enterprise networks. And in traditional enterprises, the approach involved securing the enterprise network perimeter. Okay, because traditional enterprises were not known to have a lot of external communication. When I say traditional, I'm actually talking about 2 or 3 decades older organizations. Today, of course, most enterprises have either moved part of their services to the cloud, or They have branch offices across major cities, or they have business partners and clients or customers who connect to their systems over the internet. So that whole idea of having a closed network perimeter is no longer true. But traditionally, in enterprise security, the idea was to secure the perimeter of the network. So everything inside is safe. Anything that is coming from outside can be verified, and therefore you are making the perimeter very, very strong. But we know the network perimeter is changing because of the reasons I said. Enterprises are adopting cloud, enterprises are having branch offices and head offices, so they have to do external communication. They have partners, collaborators, customers connecting to their systems over the internet. So the perimeter is changing. The perimeter is no longer a very stringent perimeter. Okay? So we'll talk about what is the approach for modern network security as the network perimeter evolves. What is the modern approach that is being used for network security? So, one of the key security appliances that is used for securing enterprise networks is a firewall, but not just any firewall. Traditionally, the firewalls used were actually L3, L4 firewalls. I mean, we also call them standard firewalls today because of the fact that they implemented primarily access control at the network, which is the L3, or the uh, transport layer, which is the L4. Okay, so you would in traditional or standard firewalls create policies that would check for source IP address, destination IP address, the type of transport protocol, TCP or UDP, uh, then the port number, source port number, destination port number of the transport layer protocol, and based on that, they would either allow or drop packets. But as attacks became more and more sophisticated, right, which means people could use a valid protocol like DNS, which would succeed in all these checks. It'll have a valid source IP, a valid destination IP, a correct TCP and UDP port number. Attacks have actually been advanced to see how they can make use of legitimate packets, for example, DNS packets, and pad these packets with additional data that belongs to the enterprise and is intended to be exfiltrated from inside the enterprise to some outward entity. So standard firewalls are unable to handle or protect against these kinds of attacks where legitimate packets are padded with confidential data to exfiltrate it outside the enterprise. Similarly, any infected documents, malicious URLs that are coming inside application payload. A standard firewall is unable to verify those because it doesn't look deep. It doesn't go to the application payload. It only checks the L3 and L4 headers to make a decision. And therefore, next generation firewalls are today becoming the mainstay for network security because they perform a more deep packet analysis. Deep in the sense that they can go right up to layer 7, which is the application layer, to investigate what is being carried inside the data and whether that data contains any confidential information like credit card number, social security number, some company confidential files, whether the data is trying to exploit certain vulnerabilities known in systems, or is it carrying some kind of viruses or spyware, or even malicious URLs. Is it carrying some URLs which are pointing to malicious websites? So an NGFW can go deeper inside the packet, way beyond the layer 3, layer 4 header, and look at the application payload to inspect the traffic for confidential data leaks, for any viruses or spyware related threats coming in the data, or any malicious URLs that are being received. Okay. So, an example, as Jyoti has also mentioned, is Palo Alto's next generation firewalls called Content ID. Anybody is interested, you can actually go and read their website as to how it implements. But the idea is to build with Palo Alto's Content ID's next generation firewall. The idea is to build a next generation firewall without highly impacting the performance. So when you go deep and you do a more deep packet analysis, the biggest concern is how much time does it require to investigate one packet coming into your network, and that adds to the latency. Right? And if you are investigating for three different kinds of threats, you are looking for at the data for confidentiality, information leak, you are looking at threats, you are looking at malicious URLs, then and each of them is done in a sequential fashion, then it adds on to the latency. So Palo Alto's Content ID, next generation firewall. I'm not specifically just talking about Palo Alto. A lot of other NGFWs today use that approach. It's called stream processing. So you actually treat the incoming data as if it is a stream of bits. And it's a single pass architecture. They call it an SPA, single pass architecture, where the stream of bits are being passed in. The content ID firewall is actually screening for all three kind of threads in parallel, not in sequence. Um, by looking at the stream of bits coming in, and as they are being processed, they are also passed out to the rest of the network. So it's minimum latency, but deep packet analysis. So next generation firewalls have a very, very unique design, which allows them to do a much more deeper inspection of the packet than the standard firewalls could do. But despite this fact that next generation firewalls are able to do a deep packet analysis, there are certain attacks which can still not be protected with an NGFW. An example of such an attack is a distributed denial of service attack. Okay? Now, an example of a distributed denial of service attack. Okay, how many people have heard of this DNS server attack? A very classic attack taught in many courses on cybersecurity. Anybody who's come across this, the DNS attack? So it's a distributed denial of service attack against the DNS. Now, it's a course in networks. I'm assuming everybody knows what a DNS service is. It's a service where you send a DNS request. Okay, Jyoti is aware of it. That's good. So you send a DNS request to a DNS server. So what you have is a collection of DNS servers. And as a client to this server, you send a DNS request saying, I have a fully qualified domain name like www.amazon.com, and I need the IP address corresponding to this. Okay. So I send a request, DNS request to this DNS server. The DNS server looks up its database and tells me back, okay, for www.amazon.com, the IP address is x.y.z.a. So that's what a DNS service does. It's the mainstay for the internet. When I type www.amazon.com on my web browser, the web browser eventually reaches out to a DNS server, gets the IP address so that it can make an IP connection to the server, TCP IP connection to the server. Now, in a denial of service attack, my intent is to make this DNS server unserviceable. And how do I do that? I create perfectly well-formed DNS queries. Okay, it's a perfectly well-formed DNS query. So no next generation firewall will flag it because it's a perfect uh, query being sent to the server. But what they would do is employ a lot of bots, which are distributed machines from across the globe, and try to bombard this server with bogus DNS requests. When I say bogus, it doesn't mean wrongly formed. They're all well-formed requests. But bogus in the sense that nobody is interested in the response. They're just bombarding the server to make the server busy. And when the server becomes busy, a legitimate user who's trying to resolve his or her query legitimately sees a lot of latency in the response coming from the server. Most of the time, the response will time out. And you will see an error on your web browser which says that the site www.amazon.com is unreachable. The reason is because the IP address could not be resolved. But you believe the internet has gone down. In reality, it's an attack being executed against a DNS server. So DIN DNS attack was such an attack that was executed, brought down a major part of the North American subcontinent internet access. Most of the websites went down because IoT devices were used to as bots to send a lot of bogus DNS queries to DNS servers, which brought down or made the DNS servers unserviceable for legitimate users. Now, if you have this kind of an attack, for an NGFW, it's a perfectly formed DNS query. So even if I look at the application payload, it's perfectly fine. There's no malicious URL. It's a well-formed DNS query. It's as per the protocol. But NGFW will likely let it pass through. So for such kind of attacks, to protect against them, you need different appliances which can look at such kind of intrusion attempts and prevent them from occurring. Okay, so intrusion detection systems and intrusion prevention systems. Sometimes we club the two together and we call them an IDPS, intrusion detection and prevention system. Is a device which is able to detect such kind of intrusions, or a DDoS attack can very easily be detected by an IDPS, because IDPS devices have various detection methods which help them detect these kind of attacks. So IDPS devices use a combination of multiple methods to detect attack. One is so they look at behavior, they look at anomalies, and they look at signatures. We'll quickly talk about each of this. So by behavior, I mean what is the general behavior of your network. So normally, what kind of traffic does my DNS server see on any normal day? So on any normal day, if I plot a graph, I see, okay, this is the time of day as the day progresses. This is the volume of traffic or DNS queries that I see. I say, okay, this is how it changes. This is how my DNS traffic is, right? So I'm just plotting, and this is part of your network observability. I'm observing what kind of traffic pattern I see for DNS queries coming in. Now, once I've been able to observe my network and know that this is my general traffic, I can define a band. I can say from minimum this much to maximum this much is what I see as the traffic, DNS traffic. But on one fine day, the traffic starts like this and suddenly shoots up to some very high levels. And this is what my IDPS detects as an anomaly. It's a change in the behavior of my network. So behavioral analysis is a form of, you can say, artificial intelligence that the platform has, where it determines the general or normal behavior of your network. It includes things like which systems communicate to which other systems, what protocol are they using to communicate, which is what I mean by how they communicate, how much through they communicate, which is what we saw over here. So it generally gives me a very normal behavior. It helps me understand the normal behavior of the network. As soon as I see certain outliers, those are deviations which could be potential attacks. And this is what an IDPS system is able to immediately highlight or alert or raise an alarm on, because it could be a potential DDoS kind of an attack. Now, the challenge with behavioral analysis, though, is that it has its own shortcomings as well. One, it requires you to create a good baseline view of what is the normal network behavior. Okay? Now, when you're creating that baseline view, if the network is already under attack, you will baseline the malicious traffic also in your standard traffic or normal traffic, and that creates a challenge. The second issue is there is a chance of false negatives being highlighted. Let's say Amazon.com has that Diwali festival sale going on. So it is expected that the traffic to the servers will go beyond the general normal behavior that the network observes, because it's a sale period. So false negatives are quite likely with behavioral analysis techniques, but they are still a good approach to detect potential DDoS attacks, which an NGFW may not detect. IDPS systems also, besides behavioral analysis, have other methods, and generally they use a combination of these techniques. They also have anomaly detection approaches. So in anomaly detection, they look at malformed packets, in the sense that they understand how the RFC specifications or standards define the protocols message structure. So this field followed by this field and then this field, we saw that every packet has a packet format. Any packet which is manipulated, which doesn't have the right format, is said to be wrongly formed, and that kind of anomaly is something that IDPS systems can also detect. IDPS systems also, like your anti-viruses, have a signature-based detection method as well, where they can they have a database of known patterns of malicious packets, which is kind of called a signature for malicious packets. And IDPS systems will look for these kind of signatures or pattern matches in your incoming packets. And when such a when such a pattern is found in your incoming packet, they determine that it is a potential attack and can take a predetermined action that is configured by the network administrator. So using a combination method, see all of these techniques have their own shortfalls. Signature based requires you to have a pre-understanding of attacks. So it can detect the most common and generic attacks which have already been detected. And for them, you have a known pattern or signature in your database. But it cannot prevent a 0-day kind of an attack because something which has not been detected, a signature based method will not know. Similarly, anomaly detection is very difficult to do for the tens of thousands of RFCs that exist in the internet world. You can do it for some key protocols, but not for every protocol that exists. That will become a very daunting task. So generally, IDPS, IPS systems use a combination of all these three methods to do a good job at detecting attacks or intrusion attempts and thereby detecting them. So uh, when I follow the defense in depth strategy, what I do is I will have a firewall as the first line of defense. When some traffic passes through the firewall, I will pass it to an IDPS. So that becomes the second line of defense. So essentially, each device, the firewall, the intrusion detection, have their own pros, yet have their own shortcomings. And when I create a line of defense using the defense in depth approach, then the shortcomings of one are taken care of by the other and vice versa. And overall, this line of defense creates a pretty robust network security with technique. So firewalls, IDPS systems, they have been the mainstay of network security. Okay, before I go to how do you secure network services, I'll highlight one more technique which is very commonly used and even though it looks very simplistic, it's a very commonly used technique for network security, which is called network segmentation. So we saw that the internet, when we looked at the internet structure, we saw the internet is actually a network of many smaller networks. So the internet is not one big flat network, but it consists of many smaller autonomous systems which are independent networks in their own right. Now, what that means is that if there's a particular attack that happens against one autonomous system, it is contained within that autonomous system. It doesn't naturally spread to the rest of the internet because there are controls. Every autonomous system will have its own lines of control like the NGFW, IDPS. So it prevents the attack from spreading. Network segmentation is a similar approach but applied to a single network, a single enterprise. So if I have an organizational network, rather than keeping it as one large flat network, I segment it into smaller subnets. Okay? It could be done based on business units. I will say, okay, this is HR. All HR machines or systems are in one subnet. All finance servers and machines are in another. Or engineering department machines are in the third one. So I can divide them into segments, and between segments, I can put in firewalls. Okay. So I will say normally traffic from HR segment is not allowed to go into engineering or vice versa unless the firewall rules allow. Okay. So that also is a very strong approach to implementing network security because what it ensures is that if some machines on your network get infected, the attack just doesn't spread like wildfire. Internal firewalls within network segments are able to prevent the fire from spreading or the attack from spreading within your network because of the network segmentation approach that you used. Okay, so it's a very important approach that is often used for network security. So three things that we talked of in order to protect our network. One is the next generation firewalls. Second is IDPS systems. And third is the approach of network segmentation. Okay, the other thing that we want to talk about from network security standpoint is that network security is not just about protecting the network from any intrusions. It's also about protecting the network services that are being used within an organization. So every organization, if you look at, it leverages the internet services today. DNS, as we just discussed, is the mainstay of the internet. If I have to use the internet, I must have a DNS server configured. That's the only way I can. Otherwise, I'll have to remember all these IP addresses, which is very difficult. But it's easy for me to remember www.amazon.com or google.com or icicibank.com because a DNS server will eventually resolve these names to IP address. DNS is a key service for any organization. Similarly, emails is something which has become a mainstay for our communications today. Any data exchange often uses file transfer protocol. We use file transfers for data exchanges. So if there are malware threats that are directed towards any of these services, we just discussed the DNS service attack. That was an attack that brought down the DNS service and eventually brought down the internet. Network security aims to protect against such attacks as well. Okay. So how do you keep your network services up and operational? DNS service, email service, file service, even your web. So today, a lot of our customers, clients. So for you all students, the LMS is a web portal that you use for all your educational needs. If the LMS system goes down, it's a big issue. So how do you keep your web services also up and running? That's also securing network services is also a part of network security. So DNS security is often implemented. Okay, before I get to how it is implemented, one way that DNS could be brought down is what we discussed, the DDoS attack. Right? The other issue with DNS service, I'm not sure if there's any slide which captures. Yeah, okay, it briefly mentions here. The most prevalent DNS attack that exists is DNS poisoning. So we said, what does DNS do? I give it a domain name like www.amazon.com. It gives me an IP address. Now, to do that, the DNS server relies on a database where it has kept a mapping between the domain name to the IP address. Now, if somebody were able to poison the records in this database, this is where the name DNS poisoning comes in, and replaces the legitimate IP address corresponding to Amazon.com with a malicious IP address. So I poisoned the record, DNS record. Then what will happen? Anybody searching for www.amazon.com, the DNS server will reply back with the malicious IP address. And all users unknowingly will be led to a malicious website, which may ask the users to log in via their Amazon user IDs and passwords, thereby stealing their credentials. So what is essential is to make sure that these DNS records cannot be poisoned. Now, how are these DNS records poisoned? There are two ways in which these DNS records get poisoned. The simplest is if I can set up my own malicious DNS server. I am a malicious user. I set up my own DNS server and I put in wrong malicious entries in my database. So anybody contacting my DNS services will get malicious responses and thereby I can implement DNS poisoning attack. The other method is no DNS server in the world can have the mapping of every domain name to every IP address because there are billions of systems and servers all across the globe. No single DNS server can have billions of database entries for every domain name to IP address mapping. So DNS is a collaborative system. There's a family of servers which collaborate to solve the DNS problem. So if I send a DNS query to my normally at home, when your browser, when you on your browser you type www.amazon.com, your laptop is configured to reach out to the ISP's DNS server. So if you're taking services from Airtel or Geo, your ISP has configured a DNS server in his network. The requests go to the ISP DNS server and they are responded from there. If the ISP DNS server doesn't have a mapping, it goes to the next tier DNS server. So DNS servers collaborate. Right? They talk to another one saying, I was asked for a mapping which I don't have. Can you help me? Right? So it'll fetch the response from some other DNS server and then reply back to you. Okay. There is also a concept of zone transfers. So when these DNS servers collaborate, they exchange information that they are aware of. So I will share with other DNS servers the domain name to IP address mappings that I have, and he or the other DNS server will share its mapping with me. This is called zone transfer. So essentially, DNS is a collaborative service. So DNS servers do collaborate amongst each other, and there is a big potential of poisoning the DNS entries when such kind of collaborating DNS servers exist. Okay. Okay. Pradeep has put something. Let me read that. For DNS mapping at Cloudflare, they are providing Cloudflare IP ranges instead of our infra IPs. Is it because to avoid the DNS poisoning? Okay. So Cloudflare, okay, so not this is not necessarily to prevent DNS poisoning. Cloudflare, by the way, is a very well recognized, known DNS server. So it's an authentic DNS server. Right? So if you are using Cloudflare for IP address resolution, domain name to IP address resolution, then you are pretty confident that you are getting the right responses. DNS poisoning happens when Cloudflare's entries, record entries, get uh, become incorrect because Cloudflare is fetching information from other DNS servers. Okay, and those other DNS servers are malicious DNS servers. They are providing Cloudflare with malicious IPs. The range of IPs that Cloudflare provides instead of your infra IPs could be for various reasons. It could be for hiding the internal structure of your internet. It could also be for load balancing purposes. So there's a range of IP addresses so that traffic could be distributed across one of these IP address rather than a single IP address. So that could be for various other reasons, for load balancing, for network configuration hiding. But DNS poisoning will happen when Cloudflare, which itself may be authentic DNS server, but its records get poisoned because it is also fetching the data from it's collaborating with other DNS servers. And some of those other servers may be malicious servers. So the method to protect against this kind of malicious uh, record poisoning is by using what a standard called DNS security. This is a standard defined by the Internet Engineering Task Force, which is our standardization body for all internet protocols. And what the DNSSEC defines is a set of techniques whereby uh, the record poisoning can be prevented. So one, it provides a method for verification of peer DNS servers before you approach them for any DNS resolver data. So I just don't go to any DNS server. I have some well-known partner DNS servers. So Cloudflare would know that, okay, I can go to a few other well-known DNS servers to get my records if I don't have a mapping. And those well-known servers with whom I'm collaborating, so that nobody can masquerade them, I implement some method for authentic verification. So I first verify that the DNS server that I'm communicating. So in your example, for example, Pradeep, when you talk to Cloudflare, how do you know it is indeed Cloudflare DNS server? and not a malicious server masquerading as Cloudflare. Because Cloudflare DNS server will provide you with a digital certificate or some method via which it is able to authenticate itself to you. And therefore, you know that you're talking to the right server. So DNSSEC enforces a method of authenticity by introducing methods for DNS servers to authenticate each other before they communicate between them. Before even they are doing zone transfers or exchanging resolver data, they first authenticate it themselves. So DNS security introduces a method of authentic exchange by authenticating the peer node, making sure it is what it claims to be and not a malicious user. Two, it says that zone transfers should be done for only limited information. See, when I run an enterprise, like we are running Bits Pilani network, there are a lot of these servers that are internal for Bits Pilani's own use. The employees log into a payroll server to see all their payslips. So as an employee, I actually type something like payroll dot bits-pilani.ac.in. This gets resolved to an IP address of a payroll server, which helps me access the payroll server and see my payslip. So eventually, Bits Pilani's DNS server has this mapping between the payroll server's domain name to IP address. But should I be sharing this record to another DNS server outside the Bits Pilani system? No. Because other than the Bits employees, nobody else in the public internet needs to access this server. So why should the domain name to IP address mapping of this server be exposed on the public internet? So the second thing which DNS security highlights is the importance of limiting zone transfer. Zone transfer is exchange of these records, DNS records, amongst collaborating DNS servers. Limited to only those records which point to servers that are publicly accessible, which can be accessed from outside, not every record. DNS, for example, also has some special kind of records called text records. Text records are actually there in a DNS server to carry some information that is relevant for the enterprise. An example of a text record is every DNS server machine has a system administrator. So a text record may store information like system admin name, who's the system administrator for my DNS server, what is his mobile number, what is his email address. These are all stored in a text record. Why should somebody outside my organization be able to see all these details? So DNSSEC enforces limited zone transfer information exchange so that only relevant records are exchanged between partner DNS servers. Okay, so authentic exchange is only allowed, limited exchange is what is allowed. And this actually strengthens the DNS system, preventing it from any kind of record poisoning that may happen. So this is what DNS security as a suite of standards defined by the IETF brings in to strengthen the DNS system. Okay, email is the next important service that all organizations use. It's also considered a network communication service, so it's a part of network security. And the emails, if you look at today, there are various ways in which organizations have started leveraging email services. One, see, traditionally, every enterprise used to have its own mail server. And they would have their own email server, which would cater to their own employees, clients, customers, and so on. But as cloud-based services have grown, enterprises have already started moving their email services also to the cloud. So all our emails, which might read as first name dot last name at WILP dot bits-pilani dot ac.in, in reality, it's not a mail server that Bits owns or manages. These emails are all handled by Google Mail. Okay? So we take Gmail services It's a as a service implementation is actually SaaS, software as a service implementation of the email service, and it enables us to scale without having to be burdened by managing user email accounts. So as soon as, let's say, a semester starts and there are some 20,000 students onboarding the semester, it's not as if we have to configure those 20,000 emails. The IDs of the students are shared with Google, and Google will create those accounts for all students. And it's software as a service implementation. So enterprises have started to move their email implementations to the cloud. Okay. On one hand, it means that now enterprises have lower control over their own email security. We don't control the email security. But on the other hand, if you're using or employing the services of a renowned cloud service provider like Google, then you're pretty sure that they have stringent email security techniques already implemented. Okay? So when we talk about email security, what is it that what is the biggest threat that we are protecting emails against? The biggest threat with emails comes from spam emails. Okay? Spam is not just loss of productivity. It's not just unintended information flooding your mailbox. It also is one of the most popular methods used to spread malware and therefore impact or infect computing systems. When I receive spam, okay, I am not just on the receiving end of receiving malware or unwanted emails in the form of a spam receiver. If I wrongly click on that spam email and it includes a malware or some piece of a virus, I could even become the source of spam. Okay, my machine could get infected and I could become the source of spam. In a way, I could be used as a relay. So I first get infected via a spam email, and then that infected machine that I'm having becomes a source of spam email, spamming many other people. So I'm being used as a relay node, receiving spam email and forwarding it to others. So, and by the way, this is quite risky because there are these tools that exist on the internet which are always monitoring the source of spam emails. Okay. So when spam emails are being sent over the internet, there are certain kind of tools which look at the originating network from where the spams are being generated. And when the tool determines that a particular subnet is generating all the spam emails, it actually cuts that subnet out of the rest of the internet. So all DNS entries, everything are modified so that the subnet is cut out of the internet. Right? So such tools exist. Now, if I get infected, if my machine in my enterprise gets infected because of spam email, and I become the source of spam emails, and if such a tool detects it, then what will the tool determine? The tool will determine that which Pilani subnet is the source of these spam emails. So what will it do? It will cut off which Pilani subnet from the rest of the internet. That's an even bigger problem. I've lost all my network services. So spam emails can cause very serious network challenges for organizations, and therefore protecting against spread of spam emails is very important email security requirement. So to do this, we employ a special kind of a firewall, which is called a spam filter. Right? So it's a special purpose firewall because it doesn't care about the other traffic. All it's caring about is email traffic. It has to be SMTP, MIME, SMTP, IM, PS kind of traffic which is incoming. It'll look at that traffic and check for any spam content in that email. So we call it a spam filter. Now, how do you introduce a spam filter in this entire system? So what do I need? So normally, if an email is sent, right, how does it traverse? I have an email sender, which is a laptop, let's say. The sender sends the email to the source mail server. So this is the source mail server. So if I am the sender, then Bits Pilani will have its own mail server. Any mail that I send to somebody in, let's say, XYZ organization, xyz.com, name at xyz.com. So I'm sending a mail to name at xyz.com. My mail will first be going to my own mail server, Bits Pilani's mail server. Now, Bits Pilani mail server receives this email and it sees that the destination is name at xyz.com. So it doesn't care about name. It checks the latter part of it, which is xyz.com. So it knows that I have to send this mail towards the mail server of xyz.com. xyz.com is an organization which has its mail server. I have to send the mail to that mail server. How do I do that? I need the IP address of this mail server. What do I have? I have the domain name xyz.com. What I need is the mail server's IP address. So what comes in handy? I will go to the DNS. I will go to the DNS. I will say xyz.com is the domain name. I don't want IP address of any server. I need the IP address of the mail server, not the web server, of the mail server. So DNS has some special purpose records called mail records, MX records. Okay. MX records actually are records that keep a mapping between the domain name like xyz.com to the IP address of the mail server. That's why the name MX record. So DNS will give me the IP address of the mail server of xyz.com and that's how I will reach the mail server. Once the mail server of xyz.com gets this email, it will look at the name and either push that email or wait for that named client to pull it from the mail server. Okay? That's how mails traverse. Now, if I have to introduce in this path a spam filter, where is the right point to put it? The right point to put it is in front of the recipient's mail server. The recipient wants to protect himself or herself from spam email. So xyz.com wants to have a spam filter put in front of the mail server so that any spam emails are first filtered out before they come to the mail server. How do you do that in this whole system? So all that I need to do is go to my DNS server, change the MX record so that earlier xyz.com was mapped to the mail server's IP address. Now I change it and I put the spam filter's IP address. So none of the other world is impacted by it. Nobody else gets impacted. They are not even aware that there's a spam filter configured at the recipient end. Okay? They would just go to the DNS asking for the mail server for xyz.com. The difference is now instead of getting the IP address of the mail server, they will get the IP address of the spam filter, but they don't know. So they will send the mail to the spam filter thinking it's the mail server. The spam filter will receive that mail, filter the spams, rest of the emails it will send to the mail server. Okay. So when I do this spam filtering, because of the way that we just discussed, spam filtering can be done. Even if I have my own mail server inside my enterprise, so this is my enterprise network. Okay, these are my internal machines. This is the demilitarized zone, DMZ, of the organization where the firewalls, the IPS are all configured. I also have the mail server here. Okay? I can still have the spam filter somewhere on the cloud. I don't need to have it within my enterprise as a mandatory thing. I can have it anywhere. It could even be in the cloud. So all emails can first be routed towards the spam filter, and then only successful emails which pass the spam filtering checks can come to my mail server. And this is how I can protect myself against spam emails. Right? So should I use a spam filter on the cloud? Actually, the spam filter I could even have within my enterprise in my DMZ. So what is the benefit of using a cloud-based spam filtering service? Well, it becomes zero or limited administration for me. Let's say Cloudflare has a spam filtering solution or Google has a spam filtering solution. I'm just configuring their spam filters as my in my MX records as my mail server. So I don't have any administrative overheads for filtering spam emails, but I will get the benefit of reduction in spam traffic and also reduction in any malware and other threats because the spam filter will check for malicious URL, malwares carried in emails. Uh, I'm sure many of you have received, if your organization uses a spam filter, you would have often received a mail that says quarantine. Some email has been quarantined because it contains some malicious content. And if you think that it is not malicious, and then click on a link so that it can be released. Have you seen that? Has anybody seen this? Do you ever get quarantine emails from your mail server saying that some mail could not be given to you because it's been quarantined? Because it was suspected by the spam filter to be a suspect email. Ajit says yes. Yeah, okay, Meghna says yes, Yuvraj is saying yes. So a lot of you have seen this. So this is spam filter at work. Okay. Now, the negative thing of using a cloud hosted spam filter is that it could lead to a significant cost depending upon the fee structure. I mean, if I receive a lot of email traffic and the fee structure is built on per email, eventually I might end up paying a lot of money to my cloud service provider. Yeah, so a lot of people are now saying yes, Tushar, Tanya, sorry, yeah, sorry, Sanjay, Tushar. Second, it doesn't allow me control over the spam filters. I'm using a cloud service provider's spam filtering service. I can't control the filters. And the third disadvantage is that if the spam filtering service goes down, because the DNS records are mapped such that all my mails will go to the spam filter. If the spam filter has a service failure, I'll not receive any emails. Or there'll just be unwanted delays in my emails coming in. So it's a trade-off. Should I use cloud-hosted spam filtering or should I have my own spam filter set up alongside my mail server in my own enterprise? In which case, of course, I'm investing in buying and procuring the spam filter, but then I have more control over the filters. I don't end up paying a pay-per-use cost. And if my spam filter goes down, because the my own DNS is handling these MX records, I can quickly change it to start pointing it to the real mail server. Of course, spam filtering service will go down, but my mails will not get delayed or lost. So that kind of a cost benefit analysis enterprises typically do before they decide whether they want a in-premise spam filtering service or whether they want a on-cloud spam filtering service. Yeah, so as Sanjay says, if cost is a priority and availability, so a lot of these renowned cloud service providers will have a very highly available spam filtering service. It's if you're taking a service from a reliable uh, service provider, then it's always better to go to a cloud hosted high availability spam filtering service because they are experts at it. So if I want to install my own, then I have to have an IT team which manages the spam filter, keeps on upgrading it, right? And so on. Okay, Ajit's question, how to decide a logic to detect spam mail? So Ajit, the logic is similar to what your NGFW has. It relies on deep packet inspection. But the only difference is that while an NGFW will look at all kinds of protocols, a spam filter is restricted to only look at SMTP, MIME kind of traffic, only email traffic. So it'll do a deep packet inspection of your email, see if there are any malicious URLs, which are already blacklisted URLs. It will maintain a database of all malicious URLs, malicious IP addresses, um, subnets which are generating spam emails. If any email is coming from there, it will drop it. Right? So it does a deep packet inspection. Right? So so email traffic is protected using spam filters, while DNS traffic is protected using DNS security. Okay, I had this slide on network segmentation. It was coming in last. But anyway, we've already talked about the network segmentation strategy and why it is beneficial. Okay, so very quickly, yes, there's much more to network security. Um, there are topics around how do you protect your web portals and web services. So generally you use a special type of firewall called a web application firewall. You use web application firewalls to protect your web services and web app. When your employees need to access the internet, how do you protect any data being exfiltrated? You use proxy web servers, so web proxies. You would have seen this in your enterprises. Web proxies are configured, so you don't have direct internet access, but you always go via web proxy. Right? So there are a lot of other topics in network security, but we just touched upon some of the key things to give you an idea of flavor. Okay, one question, sir. The con service failure means for cloud spam detection. Service failure means that you will not get any emails because all emails are being redirected to the spam filter. If the spam filter is down, then you don't get any emails. Okay, so all email services are down for you. Or if there's a queuing support at the spam filter, then they are getting queued and not sent to you, so you have unwanted delays. Yeah, okay. Deep has a question. If we send mail to blocked employee mail from organization, will receive quarantine mail back from mail server. Yeah, I mean, that is what most spam filters will do. If you say that, no, I want to receive this quarantine mail, I trust the source of the email, the content of the email, then it will be released. It will come into your mailbox. But then you've kind of given a authorization. If anything untoward was to happen, you are actually responsible for it. So when you give an authority to release a quarantine email, you have to be very, very careful. It's kind of giving an authorization. And if later that turns out, if it has malicious content and you click on it and some uh, security issues arise out of it, then you become the source of that. So you have to be careful. It's kind of a warning system, but it's quarantine is more of a warning system. But then sometimes, as responsible employees, you are given the benefit of doubt, and you are required to. You can say yes, please release this email. It's important for me to see. Okay, so that's a quick overview. Now, with that background into network security in general, we will look at how cloud network security is implemented. In a sense, we'll talk about, so we've looked at overlay networks, which are, we said, my virtual networks, tenant specific virtual networks in Amazon, with AWS, we call them VPCs, but in reality, they are tenant specific virtual networks that are set up on the cloud. How do I protect these virtual networks? What is the perimeter or boundary of these virtual networks? How do I secure the network perimeter for these virtual networks on the cloud? How do I secure network services on the cloud? Right? So that's what we will talk about in this part where I touch upon cloud network security. Since it's near to the 1 hour boundary and it's a good logical point to break, let's take a 5 minute break and then come back and complete this. So 11:29 by my watch, 11:34 will start. Okay, take a 5 minute break. Okay, I think everybody is back after break. Okay, so quickly, if you recap, this is the slide that we had seen when we talked about, we looked at an example VPC created on an AWS cloud infrastructure. We saw that this is what a typical VPC looks like. I mean, and especially with a hybrid cloud environment, you will have some on-premise networks. Maybe this is your head office, this is your branch office. These are enterprise data centers that you have, and then this is your cloud office kind of a thing. Your services on the cloud, and the VPCs that you've created on the cloud. This is one VPC belonging to one client, maybe, or this is VPC B, and you can have peering connections between the two VPCs so that there can be direct connectivity of or access of services across the VPCs. If you want to connect your on-prem network, you can use a transit gateway to connect to a customer gateway on-prem using a VPN connectivity. You can do that. And so we saw that, and then you can have an internet gateway which connects you to the rest of the internet. So this is what a private network looks like. Now, in this case, if I try to draw the boundary or the perimeter of the enterprise network, the perimeter is of course here, it's here, but it extends to the cloud. So this all falls into my perimeter, right? Network perimeter. So I need to protect that. How do I do that? So the defense in depth approach that we talked about is also followed in the cloud. This slide actually is Microsoft slide, not AWS. This is how Microsoft Azure talks about cloud security and defense in depth. So they say we have multi-layered security for our cloud services. Our data centers are physically secured. Nobody can just walk in. Right? So there are access control doors, there are security guards, and so on. So there is physical security. All our services can only be accessed after authentication. So identity and access services. We implement network perimeter security. We also implement internal network security, and then all machines within our networks have compute security, so host security, container security. The applications which run on these machines are also secured, so we have application security, and the data is also secure, multi-layered security. That's a defense in depth. So perimeter security and network security, which we are interested in, falls under as two layers of security in a cloud security defense in depth strategy. So, what all does cloud network security entail? One, as we said, it includes securing the virtual network perimeter. Perimeter security largely means you are trying to protect your virtual network from traffic that is coming from outside the virtual network. So that's why we are talking about more from the perimeter standpoint. Okay? But if you look at modern cloud architectures and cloud security principles, some of you may have heard of this term. Cloud security follows an ideology which is called zero trust. So the model that we use for cloud security is called the zero trust model. It's a different way to say that we trust nobody. It's not just I need perimeter security. Perimeter security, the whole intent is saying I trust everybody inside the perimeter and I don't trust anybody outside. So at the perimeter, I am putting up this border security force kind of thing, or this immigration control at my airport, so that anybody coming from outside will have to pass through this layer of security before coming in. But once they're inside, I trust them. That's the general approach to perimeter security. But with clouds, the approach uses zero trust, which means I trust nobody, neither outside nor inside. Because in modern enterprises, we've seen a lot of attacks originate from inside the organization. Disgruntled employees, third party contractors who sit within the enterprise and they steal data. So, a lot of times the threat is inside your organization, not necessarily outside. Plus, in the cloud, we've seen that the infrastructure is shared between multiple tenants. So there's so many different tenants reusing or sharing the same physical infrastructure that even people inside cannot be fully trusted. And therefore, cloud security is built on the zero trust model. So when we talk about cloud network security, yes, perimeter security is important because this is what enables protecting your virtual network from external traffic. And to do that, it uses a similar kind of combination of services like we saw in the earlier slide, DDoS mitigation solutions using IDPS, firewall services, which can be a combination of next generation network firewalls, special purpose web application firewalls. When you want to connect remotely to your on-prem networks, then you are extending the perimeter of your network from just this to also include these. So when you extend your perimeter, you want to extend it in a secure fashion. So you use VPN connections, right? So you use a virtual private network service to extend your firewall or your perimeter to other parts of your virtual or physical network using VPN services. Right? So all of this you use for implementing perimeter security, right? This we've already talked of. But what you also need, because you're following this trust nobody philosophy in cloud networks, you need to protect from insider threats as well. And that, as I spoke a little earlier, is done by using network segmentation. You segment your virtual network into multiple subnets. And this is what you saw over here also. Okay. This is a smaller segmentation, but I'll show you bigger ones as well. What have you done? I've created a public subnet where all external traffic from the internet can come in. Then I've created private subnets, which are separate so that they cannot directly talk to the internet. And any traffic from the public subnet to the private subnet can be configured to pass through firewalls. So even within my network, network segmentation introduces a second layer of network security. Okay? This is implemented often using hub and spoke topology models for your virtual networks, cloud virtual networks, and using a concept of network access control lists that can be configured in firewalls using a concept of network service group. So I will talk about this not in theory, but more by picking up the Microsoft Azure case study. I'll walk through what Microsoft Azure provides in terms of cloud network security services. And all of this, from perimeter security standpoint to internal network security standpoint, we'll actually see more from Azure standpoint, what is it that they offer, right? So instead of, since we already have a background, rather than talking more in theory, let's just pick up this case study. By the way, this slide I will not be able to share. This is part of Microsoft Azure's educator series. So it's given to all uh, educators to be used in class, but I don't have sharing rights for the PPT. I mean, sharing as in I can't distribute. So I won't be able to share with you the PPT, but the case study, when I walk through it, it will be recorded in the uh, video. So you can see it in the video afterwards also if you want to see. Let me just open it up. It's a separate slide deck. Okay, so this is a part of Microsoft Azure's security technology series called AZ500 T00A. They cover multiple topics within it, including identity. And so you saw in the defense in depth model, they claim that there is multi-layer security for the cloud infrastructure. So there is physical security, then identity and access management, then network and perimeter security, then compute security, then application and data security. So for every topic, they've created a module. IAM is module 1. This is actually module 2, where they talk about perimeter security, network security, as well as some topics we are not too interested in, host security and container security. So we are just interested from a networking standpoint, perimeter and network security. Okay, so how does Microsoft Azure as a cloud service provider implement perimeter security for your virtual network? Yeah, this slide I already shown to you. This is their Microsoft Azure slide. How do I, this is where it fits in. So my physical data center is physically secure, then any request going to any cloud resource has to pass through IAM, identity and access management. It has to be authenticated, authorized, then it will have to pass through perimeter security, then through network security, then through compute application, and then it will be able to access that data. Okay? So perimeter security fits in here. Now, when I'm talking about perimeter security, we are basically saying, how do I secure my virtual network? So this is my cloud virtual network, or in AWS terms, my VPC. This is my on-prem data center. Okay? So essentially, I have a hybrid cloud using this. Okay? This is me sitting somewhere at home, trying to use, let's say, the internet to access some of the services on my virtual network. And there are some servers within my on-prem network which might be trying to access some servers on the virtual network, maybe once again over the internet. Okay. So how do I secure my virtual network perimeter from external traffic that is being generated from the internet, either from on-prem servers or from my employees stationed globally? Okay? How do I secure this virtual network? Okay, this I'm skipping. This slide is just talking about what is a distributed denial of service attack. We've already talked about it. Yeah. So the first layer of defense which Microsoft Azure provides for your virtual network is against DDoS attacks, distributed denial of service attack. And they have a tool that they call as the DDoS protection standard tool. Okay. So if you look at this last diagram that I showed, where people were trying to access the virtual network servers from outside. In my slide, you remember there were some public subnets. So there'll be some public subnets configured. External internet traffic can only enter my public subnets, and from there they can go to private subnets. So what are these public subnets? There are some public IP addresses assigned to some of the network machines facing the internet. It can be a gateway router, right? It can be a VPN gateway, virtual private network gateway, which is terminating the on-prem VPN connection. Now it has to have a public IP address because it's accessible over the internet. Essentially, we are saying, in summary, we are saying your private network on the cloud does have some publicly accessible IP addresses, right? And this you would have seen even in our labs that you're accessing. The virtual labs that we have for our courses, they're all deployed on AWS. So when you access a virtual machine from your home to do a lab activity, that virtual machine also has a public IP address, which you can use to set up a SSH connection with it to transfer some files or data to it. You can use a PuTTY interface. So a public IP address is required if you want to access your VPC from the internet. So let's say there are two public IP addresses that are available or assigned to your VPC, public IP1 and public IP2. The DDoS protection standard is actually monitoring the traffic being received on your public IPs. This is like your behavioral analysis that I talked about in IDPS. Right? Behavioral analysis is actually all about detecting volumetric attacks. So I believe that my volume, normal behavior is this. This is my normal behavior of the network. But anything that goes beyond is an aberration, is an anomaly. and I can treat it as a volumetric attack or a DDoS attack. Okay? Just like other IDPS, so this is more like behavioral analysis. I can also do anomaly detection, check for protocol attacks, malformed packets. Okay? So this is part of Microsoft Azure security as a service. They are providing these services as a pay-per-use model. You call it security as a service. It's like software as a service, but really these are not just software only. These are kind of security appliances. It's a kind of a IDPS system. So you call it security as a service. You are purchasing these services and paying them on a per use model. So Azure provides this kind of DDoS protection tools that you can configure. In reality, when we studied our course, what did we call this kind of a function? We called it a virtual network function, right? That's what we were calling it. It's a network function, and it's a virtualized network function. And when we studied it, we said virtualized network function is a software implementation of a hardware-driven security appliance or a network appliance in general, which you can deploy on any COTS server. That is what a DDoS protection standard is. But if it requires higher performance, then I will use one of those PCI pass-through or single root IO virtualization or OVS DPDK kind of techniques to improve the performance of the DDoS protection standard. So these kind of tools can be deployed on special purpose physical servers so that the VNF performance is higher. The throughput that it can achieve is better. Okay. So this is what your Azure provides as one of the network security services. The other network security service it offers, again in a pay-per-use model, is a firewall service. So there are two variants of Azure Firewall. They call it Azure Firewall. There are two variants, standard variant and premium variant. The standard variant is what allows you to, so there are two things. One, there are policies, rules, firewall policies or rules, which traffic to allow, which not. This is the diagrammatic way of showing the internet. I use a cloud. I always draw the internet as a cloud, but many people draw it as a globe. So this is the internet. So this is allowed, this traffic is not allowed. How do I define that? By defining policies on traffic, incoming traffic. Now those policies in Azure Firewall come from two sources. One is what I configure as policies. So as you can see, Azure Firewall is like a next generation firewall because it allows me to configure policies at layer 3, layer 4, right up to layer 7, application layer. So it has deep packet inspection capabilities. Okay, so I can, as a user, configure some L3 to L7 connectivity policies. I can say, look at my application payload, and if it is a DNS traffic, then check for so and so field. If it is existing, then drop the packet. If not existing, let it go. So I can, as a user, configure these policies. But Microsoft also has its own threat intelligence where it is having, so it is Microsoft Threat Intelligence is a service. You can call it a tool which uh, detects what are malicious IPs that exist on the internet, what are some of the malicious fully qualified domain names, which subnets are the source of spam. So it has its own threat intelligence about the internet entities. So that also, if I configure that I want to benefit from Microsoft Threat Intelligence, if I take that service, that will also be used to configure policies in the firewall. So if there are known malicious IPs, FQDNs that Microsoft Threat Intelligence has already determined, then those will also be prohibited. They will also be configured as deny in my Azure firewall. Okay, so I can configure some policies. If I enable Microsoft Threat Intelligence, then it will also configure certain policies in the Azure firewall. And based on those configurations, traffic from the internet and from my on-prem network, they will be either allowed or denied to my VPC. This is my virtual private network. Okay? So that's the standard service. In the premium, they give you some more things. They, for example, provide you the IDPS functionality built into the firewall itself. They have the capability of TLS inspection. What is TLS? It's the modern version of SSL, Secure Socket Layer. It's actually SSL v2 is what TLS is. It's transport layer security. So it's a transport layer protocol that I use. Actually, it sits between the app layer and the transport layer. So the application sends the data to TLS, which then sends it to TCP or UDP. Actually, TLS works with TCP and DTLS, datagram transport layer security, works with UDP. So it's a layer that sits between, protocol that sits between the app layer and the transport layer, which actually encrypts your data before it goes over the TCP interface. So when you connect to a banking site and you see HTTP with a S, that means the traffic is not directly, HTTP traffic is not directly going over TCP. But it's actually passing through TLS and then over TCP. So the entire traffic is encrypted. That's why the S, secure. Now, when your traffic is encrypted, normally a firewall will not be able to do deep packet inspection because the application payload is encrypted. But in premium service, Azure Firewall does have the capability of doing TLS inspection as well. You can share the secret key, which is used for encryption of the traffic with Microsoft Azure Firewall. It will be able to decrypt your traffic, inspect it, re-encrypt it, and then send it towards you. So it includes those capabilities. Basically, that's why they call it premium service. More services. They have some web uh, related traffic monitoring capabilities, like a web application firewall functionality built in. So these are things that they provide in their premium service, but it's largely a firewall, network firewall. Okay, I'm skipping a few slides, things which are not important, I'm skipping. Okay. Microsoft Azure also offers this VPN service, virtual private network. So if I have to connect my on-cloud virtual network with my on-premise servers, then they provide what is called as site-to-site VPNs, S2S VPN. So I can have a VPN gateway as part of my virtual network. Similarly, I will have a VPN gateway here also on-prem. And between these two, I can create a site-to-site VPN. So all traffic between my on-premise servers and my on-cloud servers will pass through this VPN. They also support what is called as forced tunneling. So if there's any traffic that my, let's say, virtual servers in my virtual network are trying to send to the internet. Okay, so maybe see, let's say these are my, I've deployed my web application on the virtual network. So this front end is my web tier. This middle tier is actually my application or logical tier. And this backend may be my database tier, data tier. Now, we all know that in web applications, only the web tier is allowed to directly communicate with the internet. The middle tier and the backend tier, which is the app tier and the database tier, they can't directly communicate to the internet. That's why the three-tier architecture of web applications, web tier, app tier, and database tier. So if that is how what I've deployed on my virtual cloud, I may allow this, my front-end servers to directly connect to the internet. But if my backend and mid-tier servers are trying to connect to some internet hosted entities, I may configure forced tunneling. I may say, okay, this is not allowed directly. But if you want, I can force your traffic via the site-to-site VPN to the on-prem network, where there can be an inspection and auditing server that can look at your traffic. And if that is allowed to go to the internet, it can relay it over the internet. So direct internet connectivity can be prevented from your virtual network, but it can be routed via forced tunneling over a VPN, side-to-side VPN to your on-prem network. There it can be inspected, audited. If it is allowed, then it can be passed to the internet. So they can be, let's say, your web proxy that you normally have. When you generate some internet traffic from sitting inside the enterprise, it goes through the web proxy. The web proxy does this inspection and auditing. I can reuse that web proxy for the virtual network also. Force this traffic to first reach the on-prem, then go via the web proxy and then the internet. No direct internet access. Right? For all these back-end and mid-tier servers, of course, the front-end tier might be directly, this may be part of the public subnet and might be directly connected to the internet. So these are things that cloud service providers are today providing as a service. You can very easily deploy your cloud network and configure it using these services. You can configure an Azure firewall. You can configure DDoS protection. You can enable Microsoft Threat Intelligence for yourself. You can enable VPN force tunneling for some of the servers. These things are all available and provided by cloud service providers. Okay, this slide actually talks about the network segmentation that I was talking about. So the way the virtual networks on the cloud are configured is in a hub and spoke topology. This is the hub. The hub is the entry point for all traffic. Traffic coming from the internet, traffic coming from your on-prem network, or from employees sitting at home trying to connect again over the internet. They all reach the hub. There's a hub network, hub virtual network. It's kind of a subnet that you've created. And then, or this is the public subnet, you can say. And then there are multiple private subnets in a spoke model, hub and spoke model, which are connected to the hub. So all the external traffic passes through the hub virtual network before it goes to the spoke virtual network. That is my way of creating network segmentation. So look at this. There are these three VMs, 1, 2, and 3, which I have put into one subnet. And this is one spoke virtual network that I've created. One spoke, one segment of my network. Then VM 4, 5, 6 have been put into another resource subnet. And this becomes my second spoke virtual network. These spoke networks are connected to the hub virtual network. And inside the hub network, in a way, this hub is acting like what? It's acting like your enterprise DMZ, demilitarized zone, where you had your firewalls, IDPS systems for your enterprise. This is like your entry point to your virtual network on the cloud. So I have my VPN gateway in the public hub virtual network. Any on-prem network side-to-side VPN connections terminate here. And then the traffic from here passes to the spoke virtual network. The traffic coming from the internet can all terminate at the Azure firewall. And from there, it can go to the spoke virtual network. If some spoke virtual networks want to directly share services, then there is these peering connections that even AWS provides. You have peered virtual networks where you could define them as peered networks, so they can share services across those subnets directly, bypassing the control. Okay, so you can configure for some resource subnet forced tunneling. You can say that these VMs are running the mid-tier and backend tier of my application. So all of them, if they want to access the internet, forced tunneling is configured for them. So their traffic will go via the VPN gateway to the on-prem network and from there to the internet rather than directly. Okay. So the hub and spoke model, what does it provide you? It provides you in general when VM1 wants to talk to VM4. Okay, I erased it, but this was 1, 2, 3. This was 4, 5, 6. VM1 and VM4 want to talk to each other, they will normally have to go this route via the firewall. What was the firewall? This was your VNF, virtual network function. These are your VMs. This is when in the couple of classes back, I talked about VM/VNF networking. Right? How do I configure this networking? This is the path that I've set up. I've set up used SDN flow control rules to set up this path. This is how they subnet. So what does it mean? It means that no traffic, if there's some VM that has gotten infected here, the attack can only spread within this subnet. But it will naturally not spread to the rest of the subnets because it will have to pass through a firewall and the firewall will be able to inspect the traffic and deny some traffic if it includes some malware. So network segmentation brings in additional protection to your virtual network. And so that was hub and spoke topology and used for network segmentation. Yeah, this was all about more like perimeter security, but there is how do you implement internal network security beyond just network segmentation? Azure supports the concept of network security groups. It's a logical concept. Uh, so the idea is that you can define a group of entities, network entities, to be part of a NSG. And then you can define flow rules to limit traffic in and out of this NSG, network security group. Okay, so it is kind of restricting how your virtual network traffic can flow within the virtual network. So it is internal network security. What can I do? I can say that I have a virtual machine, and this virtual machine has a VNIC, a virtual network interface. I make the VNIC part of a network security group. Okay. So network security group can be associated with a network interface. It can even be associated with a complete subnet. I can say an entire subnet, like in the previous slide, you had a resource subnet, is part of a network security group. What this defines, so this dotted thing that you see becomes an NSG. It's a network security group. It includes certain VMs as because their network interfaces are part of the NSG. It includes some full subnets, which are also part of the NSG. Okay. And then I can say what kind of traffic from outside the NSG is allowed into this NSG, what kind of traffic can flow from within the NSG to outside. All those flow rules I can define. I can limit network traffic. Okay. So when a traffic, for example, is coming into an NSG, let's say that traffic is destined for a virtual machine. That virtual machine belongs to a subnet. Now assume that this subnet is part of NSG2. The subnet itself is attached to, sorry. So I said an NSG can be attached to a subnet, to a NIC. So let's say n subnet is completely attached to NSG2. The VM is part of that subnet, but its NIC is mapped to NSG1. Now, when some traffic flows for this VM, it will pass through two layers of checks. First, I will check whether the traffic is allowed to enter that subnet because that virtual machine is part of that subnet. So I will first check whether NSG2 rules, which are subnet level rules, allow the traffic to pass into the subnet. If yes, then the traffic will enter into the subnet. Second, I will check the NIC card or the VM is configured to be part of network security group 2. Does that allow this traffic to pass through? If yes, then the traffic will reach the VM, the virtual machine. So what we saw was that an allow rule must exist at both levels, NSG1 and NSG2, at both the subnet level and the NIC level, for the traffic to eventually be admitted and reaching that virtual machine. Okay. So network security groups is Microsoft Azure's concept to restrict traffic flowing into a subnet, restrict traffic flowing to a virtual machine by defining rules flow rules at NSG level. It's a virtual concept that they've created. You first bundle your subnet or your NIC cards into NSG, and then you say this is allowed or not allowed for the NSG. Accordingly, your SDN controller will set up certain flow rules. Right? We saw that it's possible to implement a firewall using SDN by setting up appropriate flow rules. By saying that this traffic, the action, what was SDN? It was generalized match plus forward, match plus action. Right? So if certain fields match, then allow, deny, that was the action. I can do all of this using SDN flow rules. But this is what the user interface looks like. As a user, you configure it at the NSG level, and then you define these rules, and then eventually at the backend, SDN controller will set certain flow rules in your network appliances to allow or drop. But essentially, this is all kind of network access control, and you're setting up network access control lists to prevent traffic from flowing. Same thing that you can do at networks by creating network security group. Microsoft Azure extends that concept to applications also. There is this concept of application security groups as well. Okay. So if you take that example of a web application again, and web application, as I mentioned earlier, has a 3-tier architecture: web, which connects to the internet, then application where the bulk of your logic is, and then the data. 3-tier architecture. Let's say I have 4 VMs, VM 1, 2, 3, and 4. VM1 and VM2 is running the web tier of my web application. So I can put VM1 and VM2 into an application security group, and I can call it ASG Web, Application Security Group Web, kind of highlighting that these two VMs are actually running my web tier as part of my web application. VM3 is running my logic or application tier, logic tier. So I can put it into ASG logic. And then VM4 can be running the database data tier. So I put it under ASG DB. Now we know internet traffic directly is only allowed to web tier. So I can define ASG rules to say that for ASG web, traffic is allowed from the internet. This is tick. But traffic from the internet to ASG logic, ASG DB is not allowed. No traffic can directly flow from the internet to ASG logic or DB, or even vice versa. So I can define flow rules or traffic rules, filtering rules at application security group level as well. Okay. All these VMs can be part of one NSG. They can be part of a single subnet and part of a single NSG. Yeah, that's what it shows. See, NSG1. Okay. This is also NSG1. This VM is also. But within the NSG itself, I can create application security groups also. Now I can say web traffic can talk to the logic layer, but it cannot directly talk to the database tier. Web tier cannot bypass and directly communicate with data tier. That's not allowed. This is not allowed. So that is the process you see. All of this I can do with setting flow rules at the AST level. Now, what you are seeing on these slides is the user interface. This is how Azure lets you, from a console, configure filtering rules. Okay. Lower down, all of it is being handled by your SDN controller by setting up certain SDN flow control rules in the network appliances. Okay. So this is all part of your network security. This is how virtual networks on the cloud can be secured. I think more or less. Yeah, so load balancer is not really a security tool, but it does have the benefit, like who said this a while back about Cloudflare? Yeah, Pradeep had said. So by having a public load balancer, you can prevent exposing the IP addresses of your web tier VMs to the external world. you can actually to the internet expose the IP address of the public load balancer. All traffic will come to the public load balancer. The load balancer can balance it amongst all the VMs which are part of your web tier. There can also be an internal load balancer which receives all traffic for the logic tier and then distributes it amongst all the VMs in the logic tier. Again, these load balancers are also a form of virtual network function. And what this is doing in reality is only setting up some flow rules to do the load balancing. Okay. So load balancer, as we saw, is also an SDN application. The SDN had a three-tier architecture: the application, the main controller, and then the devices. So load balancer can be an application which controls the SDN controller to set up flow tables in the network appliances in such a fashion that the traffic is distributed across all VMs. All of this is possible to do in a data center because of SDN, NFV. You have virtual network functions, and SDN allows you to configure flow rules. The user interface can be made so simple. You are configuring it all over a GUI-based interface. Sometimes you don't even need a GUI. You write script files, infrastructure as a code. Right? You can write Terraform, Ansible, all those script files, and the orchestrator will just do it all for you by interpreting the script and setting up the infrastructure. Okay. So there is a lot of cloud service providers provide what is called as an application gateway. It's a front end which terminates all your application traffic over SSL or TLS connection, secure traffic. Okay. And then it can pass it through a web application firewall if it's a web application before it reaches your VMs on the backend. Yeah, so WAF is what? A web application firewall is a special type of a firewall. It is designed only to protect against web application attacks. So web application attacks are like cross-site scripting attack, SQL injection attack. These are some common attacks which web applications have vulnerabilities against and which can be exploited. Most of the web application vulnerabilities are published by the OWASP, Open Web Application Security Project. They publish. And there's an OWASP top 10, which is a list of all the top 10 web application vulnerabilities. So web application firewall is built to protect against these known web application vulnerabilities. So it's tailor built. It's a firewall, but it's tailor built for protecting web applications. So it will spot any kind of cross-site scripting attack or SQL injection attack. It'll prevent it from occurring. All of these, I mean, what I'm showing you for Azure is also available in AWS. Most cloud service providers offer you these firewalls and all these VNF virtual network functions. Has it's not just V routers or V switches. All these firewalls and all are also things provided to you as ready to use services, which you can deploy in your virtual cloud network. Okay, I think that should be enough. More or less, you've gotten an idea of what is cloud network security and what is it that cloud service providers offer in terms of their services to on the cloud. Right. So I think we can close this topic on network security. So what is now remaining as the last topic is the topic of network observability. Okay, I think we'll not start it today because of just 10 minutes remaining in our class. Rather, I think what we can do is, okay, one thing which I should mention, I think I mentioned last time also, there's small possibility next Sunday I may not be available. Okay, during our class time, for I have some personal things to attend to. By midweek, I'll surely know. So if I'm unable to take the last class, which is next Sunday, by latest by Wednesday, I will announce. And in which case I will record the network observability topic and post the recording on Teams. And you don't need to wait for next Sunday. In that case, you can actually I'll make it available early. So you can go through that recording. The PPT also I will upload. So you can look at the PPT, go through the recording for network observability topic. Any questions, put it on Teams. channel, I'll answer. Right? I'll let you know by latest by Wednesday if we have next class or not. In the eventuality that we don't have next Sunday's class, if you have any questions about your end sem exam, right, those are some things that we still have some 5-10 minutes so we can address them now in today's class itself. Okay, so I'm just opening it up for you guys. If any question that you have, or for that matter, any question you have on any of the topics we've covered until today, 15 classes that we've had, any topic, we can take these 5-10 minutes, discuss that. Okay, Tanya has a question. Are all 16 modules part of EC3? Yes, Tanya, that's correct. I think I answered this last time also. It's a comprehensive exam. Comprehensive means the entire course will come in your end sem exam. I think I remember I said generally, it's not true for every course, but general rule of thumb that instructors follow is not more than 30 to 40% weightage they will give to pre-mid-sem. Because pre-mid-sem topics have already been evaluated during mid-semester exam. The post-mid-semester exam topics haven't really been evaluated. So essentially major focus, let's say 70% of the focus will be on testing your post midsem topics. Right? So it can be a kind of a 70-30 mix. But I also mentioned that in our course, everything pre-midsem was kind of foundational building blocks for everything that we did post midsem. So in any case, your pre-midsem fundamentals have to be very strong in order for you to be able to attempt anything which is post midsem. So in general, yes, the answer will be then yes, all 16 modules have to be very well prepared for you to be able to take the comprehensive exam. But questions you will find more, maybe 60-70% weightage more on the post midsem topics and lesser weightage, 30% max weightage on the pre midsem. That's how the distribution could be. Okay. For pattern of exam, you can check the last year paper, last semester paper. That's already uploaded on the LMS. I'll give you a flavor of what kind of exam uh, comes in mid end sem comprehensive, because comprehensive is different from your mid sem. Comprehensive is an open book. So unlike mid semester exam where I can ask you questions which are even directly out of the slides sometimes. I can ask you in a midterm exam, how do you differentiate between link state routing protocol and distance vector routing protocol? This kind of a question I can't ask you in an end-sem exam because you have the slides with you in front of you, open book exam. So the paper has to be more applied. It has to be testing your knowledge more than testing anything which is there in the slide already. Manish, for your question, it is already there. I already notified it by an announcement also. One consolidated PDF with the bits watermark has already been created and uploaded to the Teams folder. It is only that you can take a printout of and get it binded and carry to the exam center. Okay, so it's already there. I have uploaded that consolidated PDF which has a bits watermark. You can print it, bind it, carry it. So anyway, when you prepare, don't focus so much on remembering or mugging up things because those slides are going to be with you. Yeah, textbooks, if you have, you can carry. I never use textbooks in any of my contact sessions or classes. So if you have textbooks and you find the textbooks useful, carry them. But I mean, practically, I would say just the slides are also sufficient. The way I explained, the exam is not going to be an exam where referring to a lot of textbooks or reference material will be any beneficial. Even the slides are going to be more or less sufficient. It's more important to understand, and that's what I was trying to say. Don't mug up things. When you study, try to understand fundamentals, concepts. If the concepts are clear to you, you will be able to attempt the NSEM exam very easily. And if at all for reference you're forgetting something and you want to refer, you always have the slides. There's no reason why you should mug up anything. You can always go back to slides, refer it, and then apply it in the exam. Okay. So yeah, Varun, Yuvraj, the study tips. This is my study tip to you. Don't try to mug up anything. Focus more on fundamental knowledge and understanding of concepts, so that application, if there's a paper that expects you to apply that knowledge, you'll be able to do that. Varun's question, will we be allowed to write on final PPT? No, no, no. So you can have separate handwritten notebooks, handwritten notes in the form of notebooks, which you can carry. But on the PPT, you cannot make any handwritten notes. That's prohibited. Right? Carry a separate notebook with your handwritten notes if you want. Yeah, Pradeep, the question examples, if you're asking for, look at last year's semester paper. That'll give you an idea. What is a open book end semester exam? How does it look like? So those examples are already there. Look at last semester paper. It is a good example of what you can expect. Yes, Monish, handwritten notes in the form of a binded notebook, not loose sheets. Loose sheets are never allowed. Okay? No form of loose sheets will be allowed to the exam center. So handwritten notebooks and watermark slides which are binded, you can carry them to exam center. Okay, you can carry textbooks from publishers, but as I said, I never used them for this course. The slides should be more or less sufficient. If you have textbooks you want to carry them. But they have to be textbooks prescribed in the handout, not just any textbook. Okay, because those are things invigilators and all they will check at the exam center. Right? So I think don't worry so much. As long as you've been attending classes, you understand the concepts, you'll be good. There's no mugging up required anyway for this kind of a course. It's a course on networks is anyway a very design oriented conceptual course. There's no tools or commands that you have to remember. It's not like a Linux or a programming course, right? So nothing that you have to remember as such, just the concepts have to be clear. Okay, guys, let me wish you all the best for your final exam, just in case we don't meet next Sunday. And all the best for your final exam. You still have 3 more semesters to go. We will definitely some point meet again, maybe, and all the best for the rest of your uh, degree program. Thank you very much, and I'll let you know about next Sunday by midweek. Thank you, guys. Bye bye.